Hello, my name is Jay Haskamp, and I'd like to welcome you to another Tech Talk by Frontier Precision. Today's discussion is going to be how to match any project reference frame with Trimble's Centerpoint RTX system, or how to match Trimble's Centerpoint RTX system with your reference frame in a real-time survey. First, let's start with answering the question, what is Centerpoint RTX? Centerpoint RTX is a subscription-based correction source offered by Trimble for real-time surveying. It is available for only R10 receivers. The system is available worldwide and offers an accuracy of less than 4 centimeters. It allows for very fast convergence times and allows users to get corrections either via the internet or from a satellite. There's no need for a base station or a radio to use Centerpoint RTX. Let's have a discussion about reference frames. First, it's important to know that all GNSS data within a single Trimble Access job must be in the same reference frame. This is the reference frame of the RTK base station or the network RTK reference frame that is used in the job. Corrections from Centerpoint RTX only come in the ITRF 2014 current epoch reference frame. However, not all projects that surveyors work in are on that particular reference frame. So the question is raised, how do we incorporate Centerpoint RTX data into our projects that are currently not on an ITRF 2014 reference frame? The simplest way to combine RTK and RTX data in the same job is to perform the RTK survey in the RTX reference frame, which again in Trimble Access is ITRF 2014 current epoch. This is done by setting up your RTK base on a point that has been measured precisely using the Centerpoint RTX correction service, or is known precisely in that specific reference frame. You cannot combine RTX data and network RTK data in this manner unless the RTK network is broadcasting base data that is in the ITRF 2014 reference frame. The other option is that Trimble Access also allows RTK data that is not in the reference frame of RTX to be combined with the RTX data in the same job by using the RTX to RTK offset function in Trimble Access. These offsets are computed from a precise RTK point and a precise RTX point in the same physical location, and the difference is applied to all of your measured RTX points to bring them into terms with the RTK data in the project. The raw RTX measurements are stored, and the offset is applied when viewing coordinates or before performing any operations to those RTX measurements, such as doing COGO calculations or stakeout. Now, let's take a look at how to perform the RTX to RTK offset in Trimble Access. Okay, so now in Trimble Access, we're going to do our field checks to make our comparison here. So I'm going to create a new job. I'm just going to call it RTX Tech Talk. And I'm going to choose just a local coordinate system here where we're located, which will be Stearns County, which is a Minnesota County coordinate system. And the thought behind this is we're going to measure these points in a 2011 value, 2011 epoch, 2010 value. And we can compare these to our ITRF 2014 RTX values and show how we can then adjust these. So I'm going to accept my job here. And then I'm going to start my survey. So I'm going to go to measure, and I'm just going to dial into our local VRS network here because that is an easy way for us to just establish our our points that we're going to base everything off of. So I'm going to pick our CMRX NAD83 2011 mount point. So I'm getting 2011 adjusted coordinates. And my survey is starting. And then once this starts, I'm going to choose a single point on the ground that I'm going to use sort of as a base point to make my adjustment to. So I'm going to call this particular point, so I'm going to call this particular point 1 RTK. And for a code, I'm just going to call it control. So I know that that's kind of my hinge point, and I'm going to switch my method to topo point, and then I'm going to take a nice solid 1 minute occupation on this point. You want to make sure you take a nice, long, precise, good observation on your base points that you're making the adjustments to. It's only going to help you out in the long run. Okay, so I've saved this point, and now I'm going to go and just shoot 2 more reference points. So I'm going to have an RTK 100, and I'm going to take a 30-second measurement on that, and then I'm going to go shoot a mag nail on the other end of the parking lot and call it RTK 101. And we will take a nice 30-second shot on that as well. And that'll give us kind of a nice triangle of points here. Now I'm going to end my survey, keep my receiver on, and now I'm going to switch to my RTX survey. So I have my R10 here, which has RTX activated, and I'm going to hit measure under my RTX survey style, and now it's connecting. I have to pick my tectonic plate here, so I pick North America, and I'm going to dial in via the internet to this RTX solution. I can also get a satellite-based correction, but since I have internet, I'm just going to do it this way. This will speed up my convergence time and make it a little bit faster, but the results will be pretty similar. So I'm going to go back to my control point that I'm going to pair up here, and I'm going to call it 1 RTX and give it the same code control. And then again, I'm going to take a nice long, precise 1-minute measurement on this point, similar to what we did with the RTK point. Okay, and store this, and then now I'm going to go shoot the other 2 reference points too, so we can make some comparisons. So I'm going to shoot a point called RTX 100 to match up with my RTK 100, and then I will go and also shoot a point RTX 101 to match up with my RTK 101. And I have this sped up here, but we just took some nice quick 30-second measurements on each of these points. Okay, we'll store those. Now if we go to our map screen, you can see we have 2 sets of points, and there's definitely a difference between the NAD83 2011 and the ITRF 2014 values. So now in my map screen, I just want to first zoom in and show quickly the differences between these 2 points, one being in NAD83 2011, EPIC 2010, and the other one being in ITRF 2014. So I'm just going to grab both of these points, which were measured on the same point in the field, and do a quick inverse. And you can see here that we have a horizontal distance of about 3.8 feet, slope distance of 4.8 feet. So we can definitely see here that these 2 points are not anywhere on top of each other in terms of where they are. Okay, now I'm going to go back to measure in my RTX survey style, and I'm going to choose the RTX RTK Offset. And you can see here nothing's been applied, so there's no really information or precisions shown on the screen. So I'm going to hit Calc down on the bottom, and now I'm going to enter in my RTK base point, which is 1 RTK, pick it from the list, and then on RTX, I'm going to go to my list and pick my 1 RTX point. Now you can see I have some precisions calculated. So the precision of my adjustment is about 29 thousandths or 300ths horizontal and 900ths vertical. So the better we can get that precision value, the better our adjustment between our RTX and RTK is going to be. You also have some offset details that just shows the differences between the 2 points that will get applied to our RTX points after the adjustment. Okay, at this point we'll apply the adjustment, and then we will see the delta Y and delta Z offsets that are now applied to our RTX data or any subsequent RTX shots that we take. If we look at the map screen, now that we've applied our adjustment, we can see that our RTX ITRF 2014 points and NAD83 2011 points are nearly right on top of each other, and everything is adjusted as we would expect. We can also go to COGO and compute inverse, and we can add in some of our reference points. So we'll look at RTK 101 and compare it to RTX 101, which were shot in 2 completely different reference frames. But you can see now that they are adjusted, our RTX point falls within 300ths horizontally and 300ths vertically of our RTK point that was measured with VRS. So now we can be confident that any other RTX measurements that we're going to make in the field where we're using a satellite-based correction will now match into maybe previous project coordinates, whether it's in 2011 or anything that is in NAD83 1996 or anything that isn't in ITRF 2014. By using this adjustment, we can ensure that any of this RTX data we collect is going to fit virtually any project reference frame that we want to work in moving forward. Okay, now that we've performed the RTX to RTK offset in Trimble Access, I just want to go over a few more things to consider. First and foremost, make sure you use a very precise offset for your correction. This is extremely important to ensure that your RTX measurements are as precise as possible and can match your RTK measurements as close as possible. Also, RTK measurements can be used in a site calibration after the RTX to RTK adjustment has been done. However, they cannot be used before the adjustment has been done. R10 receivers need to have an active RTX subscription, and for more information on that, contact your local Trimble sales representative. And that R10 also has to be running a firmware version of 4.83 or later in order to use RTX. Lastly, to import the data into Trimble Business Center, your software needs to be at least version 3.30 or later. And this concludes our tech talk on working with RTX data in a reference frame other than ITRF 2014 and combining RTK and RTX data from different reference frames in the same project. For more information, please check out our website at www.frontierprecision.com. Thank you and have a good day.